Look up at the night sky. What do you see? Darkness. Coal black, velvety darkness sprinkled with a few scattered stars. But here's the catch. It's all an illusion. The greatest trick our eyes play on us every night. According to physics and mathematics, if the universe is infinite and filled with stars, then every point in the sky should be covered by a star's surface. No matter where you look, your gaze, like a beam stretching into infinity, should eventually hit a blazing sphere. There shouldn't be any gaps, not a single dark spot. Now, let's think about what this means. If every millimeter of the sky is the surface of a star, then the night sky shouldn't be dark. It should be a solid, blinding wall of fire. Under those conditions, the night sky would shine with a dazzling white light, and it would be about 1,000 degrees hot. 1,000 degrees. Hot enough to boil the oceans and vaporize Earth itself. In other words, if the laws of physics hold true, we shouldn't be here. But we are. And the sky is dark. That's the puzzle. The night sky should be a 1,000-degree furnace, incinerating all life. Yet what we see instead is a cold, quiet darkness. We'll explore why this paradox exists at all, why it baffled some of the greatest minds, and how the answer was found in a place no one expected. And yes, we will prove that the sky is actually white. We just don't see it. This problem is far from new. It tormented Isaac Newton. Albert Einstein wrestled with this paradox too and never found a satisfying answer. The greatest minds in history faced this mystery and stepped back. What makes this even more incredible is that the solution didn't come from a scientist. It came from a writer who found it simply by watching the sky from his window. He saw what others missed. He realized that the darkness of the night sky isn't empty. It feels like a shadow cast by time itself, hiding something far larger than we can imagine. But to understand how a poet could see what Newton and Einstein overlooked, we first have to grasp the true scale of the problem. We need to dive into this ocean of fire. So, by all logical reasoning, the night sky should blaze with white light. The reason is simple: the sheer number of light sources across the universe. To grasp how enormous this problem really is, we first need to understand just how vast the universe itself is. And that's where the numbers start to lose all meaning. Let's start small. Our sun is a single star, just one among hundreds of billions of stars in our galaxy, the Milky Way. Even that number is hard to wrap your mind around, but our galaxy is just a tiny grain of sand. The observable universe holds hundreds of billions of galaxies, each packed with hundreds of billions of stars. One comparison helps us grasp this scale. Scientists have calculated that the total number of stars in the observable universe outnumbers every grain of sand on all the beaches and deserts on Earth. Imagine scooping up a handful of sand. Each tiny speck represents a star. Now multiply that by every beach in the world, every desert, the Sahara, the Gobi, the Atacama, all the sand from the ocean floors too. And there are still more stars. Each one burns like a nuclear furnace, blasting light in all directions. Some are giants that, if placed where our sun is, would swallow Jupiter's entire orbit. Others are dwarf stars the size of a city, with a teaspoon of their matter weighing more than Mount Everest, and this vast ocean of fire shines unceasingly. But you might say distant stars must appear fainter. Doesn't their light scatter until it vanishes completely? That's the most logical objection, and it's completely wrong. Here lies the mathematical core of the paradox. To understand why distance doesn't protect us, let's use a simple analogy. Imagine standing in an endless forest. The trees grow spaced apart with clear gaps between them, but this forest stretches out infinitely in every direction. No matter where you look, your gaze will eventually hit a tree trunk, forming an unbroken wall. There isn't a single line of sight that extends into the distance without running into an obstacle. Your entire horizon fills up with the rough texture of tree bark. Now swap the trees for stars and the forest for the universe. If the universe is infinite and stars are spread evenly throughout, then wherever you look in the night sky, your eyes should eventually land on the surface of a star. So how does light dim as it travels? Here's the answer. Mathematically, distant stars do shine more faintly. But as space expands with distance, the volume we observe grows too, bringing more stars into view. This increase balances out the loss in brightness from each individual star. Imagine surrounding yourself with spheres. On the closest sphere, you see 10 stars. The next sphere, twice as far, has a surface area 4 times larger, so it holds 40 stars. Sure, each star appears 4 times dimmer, but there are 4 times as many of them. One effect completely cancels out the other. This pattern repeats with every larger sphere extending infinitely. The total light from all the stars in an infinite universe should be infinite, turning the sky into a continuous blaze of dazzling light. Every square centimeter of the sky would shine as brightly as the surface of the sun. That's what the math tells us. In 1823, the German astronomer Heinrich Wilhelm Olbers first framed this puzzle. Since then, it's become known as Olbers Paradox. But to be fair, Olbers wasn't the first to think about it. By the time he published his work, the problem had been puzzling the greatest minds for over 200 years, including the astronomer Johannes Kepler. Here's the paradox in clear terms. An infinite universe should be ablaze with light. So why isn't it? The first and most obvious assumption seemed perfectly logical, yet it turned out to be completely wrong. The first and most obvious explanation was already on the table. The only question left was why it didn't hold up. The first person to seriously tackle this problem was the astronomer Johannes Kepler. In 1610, after hearing from Galileo about the telescope revealing countless new stars, Kepler immediately grasped where this was heading. He reached a simple conclusion. The universe must be finite. Otherwise, the sky would be a continuous blaze of light. For Kepler, a man of his time, this wasn't a scientific argument. It was theological. The dark night sky stood as proof of a creator who wisely placed humanity and the stars within a cozy, limited space, like a carefully crafted box. The universe wasn't an endless, blazing chaos. It was a finite, ordered home. Science kept moving forward. Over 100 years later, in 1720, Edmund Halley, the very same person the famous comet is named after, presented a mathematical formulation of this problem to the Royal Society in London. This marked a turning point. What had been a philosophical puzzle about the dark night sky transformed into a precise scientific question. The answer, because God made it that way, no longer sufficed. People demanded a physical explanation. And an explanation emerged. It was so elegant and obvious that almost everyone accepted it. In 1744, Swiss astronomer Jean-Philippe de Chasseau, and later Heinrich Olbers himself, proposed a hypothesis that seemed to solve everything. They suggested that the light from distant stars simply doesn't reach us because interstellar space absorbs it. Clouds of dust and gas fill the space between stars. Space isn't a perfect vacuum, it's more like a fog, hiding distant lights from our view. Simple and logical. The light from countless stars exists. We just can't see it behind this cosmic veil. This idea felt like a lifeline. It preserved the notion of an infinite universe and explained the darkness. But it had one fatal flaw. What happens when an object absorbs light? It heats up. Put your hand under the sun's rays, you'll feel the warmth. Light carries energy, and that energy doesn't just vanish. It transforms into another form. Now let's apply this to cosmic dust. Each tiny grain constantly faces a barrage of light from billions of stars all around it. It soaks up that energy and inevitably heats up. In an infinite and eternal universe, this dust would have unlimited time to absorb endless streams of light. Sooner or later, it would heat up enough to start glowing on its own. At first, it would emit a faint red glow, like embers in a fireplace. Then, as it grew hotter, its light would brighten steadily until its temperature matched that of a star's surface. Dust would stop acting as a dark curtain. Instead, it would become a source of light itself. Rather than hiding the stars, it would shine just as brightly as they do. The idea of light-absorbing dust fails for this exact reason. As dust absorbs an endless stream of light, it would heat up until it glowed as brilliantly as the stars. One blazing sky would simply give way to another. Instead of fiery points of starlight, we would see a uniformly glowing dome. The result remains the same. A blinding heat. And yet the sky would still be dark and cold. Every obvious explanation turned out to be wrong. Science had hit a dead end. And at that moment, when the brightest minds fell silent, the answer came from an unexpected place. From a person whose life was as dark as the sky he was trying to understand. His name was Edgar Allan Poe. Yes, the very same, author of The Raven and The Murders in the Rue Morgue. We know him as the father of the detective story and a master of horror. but hardly as a cosmologist. Yet, in 1848, just a year before his death, he published a strange, almost mad essay called Eureka. It wasn't a scientific paper, more like a prose poem, where he laid out his own theory about the origin of the universe. He gave lectures on this topic, standing at the podium before audiences expecting poems about lost love. Instead, he spoke to them about the birth of stars. In Eureka, Poe introduced an idea that was 80 years ahead of its time. He suggested that the universe is neither eternal nor static. It emerged from a single original point, a prime particle. From the moment it came into being, it has been continuously expanding. And if the universe had a beginning, then it must have a finite age. This directly contradicted the dominant scientific belief of that era, which held that the universe is infinite in both space and time. For 19th century scientists, the idea that the cosmos had a birthday sounded like heresy. From this seemingly poetic intuition came a stunningly simple and elegant solution to Olbers' paradox, a solution that had eluded the greatest astronomers for 2 centuries. Poe reasoned, if the universe has an age, then light has had only a limited time to travel. The night sky is dark, Edgar Allan Poe wrote, not because there are few stars and not because something blocks their light. It's dark for one simple reason. The light from the farthest stars simply hasn't reached us yet. It's still on its way. Somewhere out there, deep in space, photons race from stars born at the dawn of time. But in all the universe's existence, they haven't crossed the vast distance to us. We only see the stars whose light has finished its journey. The space beyond them isn't empty. It's filled with light we just haven't seen yet. The darkness of the night sky isn't emptiness. It's the future that hasn't arrived. Eureka crashed spectacularly. Critics dismissed it as pantheistic nonsense, ramblings of a madman. Edgar Allan Poe believed this book was his life's masterpiece, the pinnacle of his creativity. He begged his publisher to print 50,000 copies, convinced it would spark a revolution. The publisher laughed and printed only 500. 17 months later, at the age of 40, Edgar Allan Poe died under mysterious circumstances, poor and unrecognized. They found him wandering the streets of Baltimore, delirious and dressed in clothes that weren't his. Poe died without ever knowing his wild idea was right. But intuition doesn't count as proof. It took science nearly 80 years to catch up and deliver 2 undeniable proofs that he had been right all along. Edgar Allan Poe had a brilliant insight. The night sky looks dark because the light from the most distant stars hasn't reached us yet. Darkness is simply light that's running late. Now, science had to prove it. The first proof centered on the most fundamental constant in our universe, the speed of light. We tend to think of light as instantaneous. Flip a switch, and the room fills with light. But that's not true. Light travels incredibly fast, almost 300,000 kilometers per second. But it's not infinite. On cosmic scales, it can even feel painfully slow. Light from the moon takes 1.5 seconds to reach us. From the sun, it takes 8 minutes. That means when we watch a sunset, the sun itself has already disappeared below the horizon for 8 minutes. We're seeing its past. Light from our closest star, Proxima Centauri, takes over 4 years to arrive. And if, on a clear night, you spot a tiny fuzzy patch in the sky, the Andromeda Galaxy, know this. The light you see from Andromeda has been traveling for about 2.5 million years. Back then, on Earth, the very first human ancestors were just beginning to emerge. Now, let's apply this logic to the entire universe. Our universe has a beginning, the Big Bang, which happened nearly 14 billion years ago. It has a birthday. That means light has had only 14 billion years to travel. This defines our cosmic horizon. Light from objects farther than 14 billion light years hasn't reached us yet. It's still on its way. This is the first reason the night is dark, the first great escape. Light from billions of galaxies simply doesn't brighten our sky because it hasn't shown up to the party yet. And that fact alone explains why the sky doesn't blaze with white fire. But that's only half the story. There's a second, even stranger mechanism at play. In 1929, Edwin Hubble spent cold nights at the observatory atop Mount Wilson in California. He methodically photographed distant galaxies and studied their light. Then he noticed something incredible. Distant galaxies were moving away from us, and the farther a galaxy was, the faster it was receding. It was as if you stood at the center of an explosion, watching fragments burst outward in every direction. At first, this puzzled everyone. Are we really at the center of the universe with everything moving away from us? No. Edwin Hubble realized the answer wasn't in the galaxies moving through space. Instead, the space between them is stretching, like the surface of a balloon as it inflates. Imagine drawing several dots on a deflated balloon, then blowing it up. Every dot moves away from the others, and from the perspective of any one dot, all the others appear to be fleeing. There is no single center. The center is everywhere. This discovery changed everything we thought we knew about the cosmos. The universe isn't a static stage where stars perform. It's a living, expanding fabric of reality, and that expansion directly affects the darkness we see in the night sky. Imagine a light wave as a spring. As a photon travels billions of years to reach us from a distant galaxy, the space it moves through stretches, and with it, the light wave itself stretches. The spring grows longer and weaker. While the light makes its journey, the expansion of space pulls its waves apart, stretching them out. This phenomenon is called redshift. The light loses energy. This is the second great escape. Light doesn't just lag behind when it wears out, ages, and fades as it travels. When a light source is far enough away, its waves can stretch so much that they shift into ranges invisible to the human eye, like infrared and microwave. The light is still there, it fills the space around us, but our eyes can't detect it. It's become too low and too quiet for us to see. And this is where things get truly astonishing. The expansion of space is speeding up. Some galaxies shine with light that will never reach Earth. Because the space between us is stretching faster than the speed of light? Never. Yes, that's possible because it's the fabric of space-time itself expanding, and the speed of light limit doesn't apply to that. These galaxies are forever hidden beyond an unbreakable horizon. They're like runners sprinting away so fast that their cries, their light, will never catch up to us. We live in a universe that's not just running away from us over time, but literally tearing apart in space. So we have two powerful forces making the night sky dark. Light from some stars simply hasn't arrived yet, and light from others has stretched so much on its journey that it's become completely invisible. But nature didn't stop there. It saved the biggest surprise for last. Remember, I promised you the sky is actually white and blazing? It's time to prove it. The logic behind the old paradox was ruthless. No matter where you look, your gaze should hit the surface of a star. The sky should be a solid wall of fire. And you know what? That logic was completely right. The sky really is ablaze. It's a continuous, white-hot blaze. We just can't see it. This chapter of the story doesn't start inside an observatory. It begins with a giant horn-shaped antenna in New Jersey. In 1965, physicists Arno Penzias and Robert Wilson were trying to tune it for radio astronomy, but they ran into one problem: a constant, quiet background noise, a faint hiss. It came from everywhere, day and night, no matter where they pointed the antenna. It didn't change with the seasons. The noise was perfectly steady. At first, they suspected radio interference from New York City. Then, they thought the equipment might be faulty. They checked everything and tightened every bolt. At one point, they even blamed a pair of pigeons nesting inside the antenna. The physicists removed the birds and thoroughly cleaned out the horn. Let's just say they cleared out the remnants of their stay. Yet the noise remained. Penzias and Wilson were at their wits' end. This stubborn, unexplained noise kept getting in the way of their work. Little did they know they had stumbled upon the greatest discovery of the 20th century. They had captured the echo of the Big Bang. This signal turned out to be the cosmic microwave background radiation, the oldest light in the universe. It was light emitted roughly 380,000 years after the Big Bang, the moment when the universe finally cooled enough to become transparent. Before that, it was a blazing, impenetrable fog. But then the fog lifted, and light began its first free journey through space. This was the dazzling white fire that the paradox had predicted. At that moment, the entire universe shone like the surface of a star. But after nearly 14 billion years of travel, this original light stretched out due to the expansion of space itself. Its waves grew thousands of times longer. The blinding white fire of the early universe transformed into a quiet microwave background, completely invisible to the naked eye. That very hiss, the one Arno Penzias and Robert Wilson couldn't eliminate from their antenna. Olbers Paradox found its most elegant solution. The sky is indeed filled with light. It's white. It's burning, but this fire remains unseen. Right now, photons from this relic radiation pass through your walls, through your body. We are literally bathed in the light from the dawn of time, the afterglow of creation, but our eyes aren't built to perceive it. To us, it's nothing more than darkness. It seems like we have the final answer. The universe's finite age, its expansion, and this invisible light together fully explain why we don't get scorched under the glow of trillions of stars. But there's one deeper layer to this mystery. British cosmologist Edward Harrison asked a simple but profound question in his book, Darkness at Night. Which factor matters more? The universe's limited age or its expansion, which causes redshift? Harrison ran the calculations and realized that each of these mechanisms alone could explain the dark sky. Nature, like a master engineer, built a double shield against blinding light. Even if the universe wasn't expanding, its finite age would be enough to keep the sky dark. On the other hand, if the universe were eternal, redshift alone would create the same effect. Two completely valid reasons for darkness. But Harrison dug deeper and uncovered the most fundamental mechanism of all. According to Harrison, the most fundamental mechanism is that stars have a limited lifespan and a finite supply of energy. It all comes down to fuel. A star isn't an eternal lantern. It's a campfire with a fixed pile of wood. Sooner or later, it will burn out and go dark. Harrison calculated that even if you added up all the energy every star in the entire universe could emit over its lifetime, from birth to death, it still wouldn't be enough to light up the sky. There simply isn't enough energy in the whole universe to burn away the darkness. Even if the universe were infinite and eternal, and even if light traveled instantly, the sky would remain dark. That's because the combined power of all the stars could never fill an infinite space with light. Infinity always beats finite energy. Edgar Allan Poe intuitively grasped this very idea of finiteness. He realized that infinite light demands an infinite source, and such a source simply doesn't exist. Every star represents a temporary, finite event, and adding up all these finite events can never produce an infinite outcome. The darkness of the night sky isn't just about geometry or the age of the universe. It reflects a fundamental law of thermodynamics, written across the largest canvas imaginable. We have solved the mystery of the past, but the darkness carries a message not only about what has been, but also what lies ahead. And that message is far more unsettling. It turns out, our time to see the stars is running out. Everything changed in 1998. Until then, cosmologists firmly believed one thing: gravity would win. The expansion of the universe, sparked by the Big Bang, should have been slowing down. Maybe someday it would stop and reverse into a collapse. But observations of distant supernovae revealed something completely unimaginable. Something that defied everything we thought we knew. The universe wasn't slowing down, it was speeding up. Galaxies were racing away from each other faster and faster, as if pushed by some invisible anti-gravity force. Scientists called it dark energy. This discovery transformed our future from a slow, fading out into an endless, lonely fall. Right now, this force is stretching the very fabric of space itself, and with each passing moment, its grip grows stronger. The consequences of this process are so terrifying, they're almost impossible to grasp. Let's look far into the distant future, 2 trillion years from now. That's a number beyond our comprehension, yet for the universe, it's just the next scene in its ongoing story. By then, accelerated expansion will have taken full effect. Every galaxy we see today through telescopes, billions of stellar islands, will vanish. Not just fade out, but truly disappear. Their light will still be traveling toward us, but space itself will be stretching faster than the speed of light. Those galaxies will be carried beyond an insurmountable cosmological horizon. The night sky will go dark. Our home will change as well. By then, the Milky Way and our nearest neighbor, the Andromeda Galaxy, will have long merged into a single enormous elliptical galaxy. This new stellar metropolis will be the only thing left. A solitary island of light in a boundless ocean of absolute, impenetrable darkness. And this is where the darkest part begins. A civilization will emerge in this distant era. intelligent beings born under the stars of this lone, isolated galaxy. One day they will build their first telescopes and point them to the sky, beyond their stellar home. What will they see? Nothing. Complete emptiness. Not a single speck of light. No hint that anything exists beyond their world. To them, the universe will be just one galaxy, surrounded by eternal, endless night. These future scientists will develop their own theories and advance their understanding. They will study the motion of stars within their galaxy and conclude that it is static. They won't detect any spreading apart, no redshift from distant objects, because their sky won't hold any distant objects at all. To them, the idea of an expanding universe will sound like a wild, unfounded fantasy. They will live in a cosmological prison, completely unaware of the walls around them. But that's not all. The greatest proof of our origins, the cosmic microwave background, the echo of the Big Bang, will vanish too. Over trillions of years, the waves of this ancient light will stretch so far that they become longer than the largest galaxy we can observe. By then, the cosmic microwave background will have stretched to wavelengths so vast that detecting it will be nearly impossible. The fingerprint of creation will be erased. A future civilization living within this merged galaxy will find no evidence of the Big Bang, no sign of the universe's expansion, and no trace of other galaxies. The entire story of the cosmos, from its fiery birth to its stellar maturity, will be lost to them forever. They will look up at the sky and reach the only logical conclusion. Their world is eternal, unchanging, and alone, and they will be completely wrong. Here it is, the greatest curse of dark energy. It doesn't just extinguish light, it erases knowledge. It creates a future where the truth about the origin of everything becomes fundamentally impossible to prove. The cosmos will commit the perfect crime, wiping away all evidence of its own birth. And in that distant future, some being will look up and see absolute darkness without a single flicker or clue about the universe's past. It will live in an eternal present, cut off from history. Now let's return to our time, to our world bathed in the light of billions of galaxies, to this era when the echo of the Big Bang still hums softly through radio waves. We live in a unique cosmic window, an incredibly narrow, precious slice of time. We arrived late enough for life and intelligence to emerge, but early enough to still witness the evidence of the universe's origin. Think about this. Before us, the universe was far too hot for life, a dense, roiling cauldron shrouded in opacity, and after us it will grow too dark and empty for anyone to observe. For billions of years before we arrived, no one could ask the question, where did it all come from? And trillions of years after we're gone, no one will be able to find the answer. We exist in a brief, fleeting moment of cosmic clarity. This is the time when the book of the universe lies open on its very first page, and we are its first readers. Our era is a rare, temporary, and slowly closing window into the history of all existence. Dark energy acts like a mechanism, steadily but relentlessly lowering this frame, and one day it will shut, forever. That's why the darkness of the night sky isn't a curse, it's a privilege. We've long thought of darkness as a lack, an emptiness, a void. But all this time we've been looking at it the wrong way. The darkness of the night sky isn't missing information. It's the information itself, about the fundamental nature of reality. Just a simple glance at the dark sky reveals the universe's beginning, its age, and its expansion. If the universe were eternal and unchanging, the sky would blaze with light. But it's dark. And that darkness tells us something profound. I'm not eternal. I was born. I'm nearly 14 billion years old. Every black stretch between the stars stands as proof of the Big Bang. The darkness between the stars tells the age of the universe. It is the light still traveling through space. It stretches into invisibility as waves of relic radiation. It marks the cosmic horizon where galaxies slip beyond our reach. The entire story we've struggled to uncover wasn't written in light, but in its absence. Edgar Allan Poe, without any scientific data, understood that the darkness of the sky holds a message, one about the universe's limits and its history. He deciphered that message long before we built the tools to do so. So, what is darkness? It's not a miscalculation, not a hole in reality. It is the explanation itself. The black sky above isn't a failure or a void. It's the universe's signature beneath its own story, the grandest text ever written. The next time you step outside at night and look up, don't focus on the stars. Look into the darkness between them. In that velvet void lies everything: the birth of time, the ultimate speed of light, the expansion of space, the echo of creation, and even a glimpse of a distant, lonely future. It's a book written in the language of nothingness, and we are incredibly lucky to live in a moment when we can still read it.